Okay, welcome to video 10.7. Today we're going to be continuing our conversation on the quadratic formula. So, as you know, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a, which is found on their formula sheet. So all you really have to do to solve these quadratic equations is to substitute in a, b, and c in place of a, b, and c in the formula. But in order to do that, as with any time we solve for the roots, zeros, or x-intercepts, we need to make sure that our equations are in standard form so that they're equal to 0. In this example, it's negative 3x squared. So I'm actually going to add that to the other side because then I'll have a positive x value, which is good, and it'll all be equal to 0. Okay, so once I do that, I get 0 equals 3x squared plus 8x minus 12, and then I have it in standard form. So off to the side, I wrote down that a equals 3, b equals 8, and c equals negative 12. I got that all from the standard form of a quadratic equation. And then I can go ahead and sub them all in to my quadratic formula. Okay, so then I filled in the negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 12, all divided by 2 times 3. Then I simplify. So negative 8 just makes it negative 8. And then when I put this all in my calculator, the way that it is, so parentheses 8 n parentheses squared minus 4 parentheses 3 n parentheses negative 12 n parentheses, notice that I'm not putting the square root in yet. I am just simplifying what's under the radical because this might be irrational. So it won't give me a nice number if I put it in my calculator. The only way to get what number is under the radical is to put all of this in your calculator and get the answer, which would be 208, but then I need to put that under the radical. And then 2 times 3 is 6. Now we need to simplify that radical 208. So off to the side I wrote radical 208, which when we find the perfect square that goes in, remember we find 208 on the list of VIPs, and then we start dividing by the numbers previous until we find the biggest perfect square that does divide in, and it's 16. The square root of 16 is 4, so this becomes 4 radical 13, which I can then put back into my quadratic formula on the left. So then I have this negative 8 plus or minus 4 radical 13, all divisible by 6. But we have to do pretzel method to simplify. So I'm going to divide the negative 8 by 6, and we do get a fraction, but that's okay. That becomes negative 4 divided by 3, and then when we do 4 divided by 6, we get 2/3. And remember that radical 13 is kind of treated like a variable, so it just comes along. It's 2/3 of radical 13. And then we still have the plus minus because this is technically two different answers. Negative 4/3 plus 2/3 of radical 13 and negative 4/3 minus 2/3 of radical 13. So it looks really messy, but that's why the quadratic formula becomes helpful for situations like this, where completing the square would have been really tough and dealt with a lot of fractions and we cannot factor. So just remember, when using the quadratic formula, you always need to first put it in standard form, identify the a, b, and c term, and then just substitute them in. When you substitute them in, always use parentheses around the variables that you are substituting in for, and be sure to simplify what's under the radical before you try to put the radical into your calculator, because it might be irrational, in which case you will have to simplify the radical as we did that with this example here. I hope that that was helpful to help you remember how to use the quadratic formula, and we'll go over it more in class. Have a good night.